About today's session, I just want to make a change or just inform you about a change. Today's session is not of a 1 hour, it's of 2 hours. So the chat is gonna be active in the last 30 minutes of the session. So our resource person today is Muhammad Asif Shami. He is an associate professor at the Department of Statistics at Forman Christian College University. He holds a master's degree with the distinction from the Islamia University of Bahawalpur. He has also worked at Pakistan Bureau of Statistics. He has been working with CLT as a resource person for the last 15 years. And he's proficient in data analysis, tools like SPSS, Minitab, and Python. Thank you, Dr. Asif Shami, for joining us today. Just a little background about SPSS before I leave the floor for Asif Shami. SPSS is one of the most widely used statistical analysis tool, and it is used across disciplines. We all know that it's not restricted to only sciences or social sciences or humanities. Rather, it's widely spread across disciplines, which makes it a very powerful tool. If you learn SPSS, no matter whatever discipline you are working in, you'd be able to conduct quantitative researches. In today's session, because it's a 2-hour-long session, we hope to explore essential features, data entry mechanism, and how to run descriptive statistics, hypothesis testing, and interpreting results. And whether you're a student or a mid-career researcher, I'm sure today's session is going to be extremely informative for you. So over to you, Asif Saab.
Thank you, ma'am. Thank you. Thank you. I'm just a student. Let me introduce myself. I'm Asif.
Sir, we can't hear you.
Is it okay?
Can we test your mic? Say something? No, we still can't. Yeah, now it's working.
You know. Is it okay now?
Please give us a minute as we fix this technical error. Apologies for this. No, we still can't hear.
Can you hear now?
Sir, say something?
Is it okay? Can you hear me?
Yes, now we can.
Thank you. Thank you. Thank you. Earlier it was working. Okay. Thank you, ma'am. Let me start with
Asif Saab, your voice is really muffled and very, very low. Just give us a minute. We'll be back. Let us fix this technical issue. Give us some time.
Sure, sure. मैडम इसके सॉफ्टवेयर में Is it okay now?
Yes.
Thank you.
Thank you so much for fixing it.
For some time, I will switch off my video for the betterment of the audio and video quality, audio quality. So if you don't see me, it's okay. Let me start with my presentation first. I am Mohammad Asif Shami, Associate Professor at Department of Statistics, Common Christian College. Why SPSS? The title of the today's webinar is Quantitative Method Using SPSS. SPSS, why? Why it is used so widely? It is very comprehensive tool. It is very flexible statistical analysis tool to make to draw decisions from the data. Data management system is very powerful in SPSS, no doubt. It is very powerful. We can take data from almost any type of data, any type of file like CSV, XA, Excel, Access, and any type. To generate tabulated reports, charts, and plots of distribution and trend descriptive statistics and conduct complex statistical analysis, SPSS is widely globally used. SPSS is now available for several platforms, which is very common, like Microsoft Windows, Apple Macintosh, and Unix system. Latest version released by the IBM is 31, and today I'm going to work with the SPSS version 27. There are four basic windows of the IBM SPSS. Why I'm doing this? Because there, if you don't know the SPSS outlook, then it is not easy to understand the output of the IBM SPSS. But there are four windows. The data editor, where you enter the data, you see the data just like the Microsoft Excel spreadsheet, but there is a difference between the Microsoft Excel spreadsheet and the IBM Outlook data editor. Number two is output viewer, where you get the results. In Microsoft Excel, you see the result on the same screen, on the same tab, and sometimes the data is being hid by the output. But in the IBM SPSS, the output viewer is different. Different window is there. Syntax editor and script windows are for the advanced level of user of SPSS. What is data editor? It is spread-like sheet system for defining, entering, editing, and displaying data. It is only for the data, nothing else. You only see your variables with all entries you have done. You do not see anything else. Extension of the saved file will be SAV. SAV is the section for the data editor to save the two different files. The next file is another one, the output viewer. Output viewer displays all the outputs and errors if there are. Extension of the file will be SPV. And now look at this. This is the SAV file and this is SPV file. If you just want to open the output viewer, you can open it. If you just want to see the data reader or data file, you can just open the data file. But in Excel, you have to both the values, both the windows are at the same time. The next is syntax editor. Syntax editor, as I told you, that is the programming, some sort of programming, and it has different syntax extension that SPS. And the next is script window. Script window is more advanced than syntax editor. So I will skip these two. The basic of managing, how to manage the data file, how to enter the data. Opening the SPSS. The data window will have the two editors. One is data view and the variable view. You will come across this. I will answer. You have sent. Thank you all the participants who sent responded me on the provided questionnaire. You will observe the two windows over there. I will work frequently on these two views. The first one, the data view, and the next is the variable view. This is, in fact, that data editor. Nothing else. The output window is separate. Data view window. The first one is data view. What is data view? Data view window, this sheet is visible when you first open the data editor. And this is contained all the data you have. The next is the variable view. Variable view is very important. Every information about the data about your concerned variable is stored here. This sheet contains all the required information about the data set. The first thing which is very important in this, let me differentiate it from the data. If you see that there is VAR, it means these are the variable names, and these are the spreadsheet like a table where you see the data. But in the data view, variable view, you have the first column as name. Name is very important. The first character of the variable must be an alphabet. You cannot start with any special character, or you cannot start with any numeric. Variable name must be unique and must be less than 64 characters. If you enter the two variables age and the next is the age, again, SPSS will not allow you to enter the same name. But if you enter a single underscore with the next variable, it will be accepted. Number two, in Microsoft Excel, naming the variable can accept the spaces, but in IBM SPSS, spaces are not allowable when you name a variable. However, you can do the underscore sign and the dot and a period with that. The next is, if you see, that is the type. Type is the number type of the variable. Like is it numeric, it is comma, it is a dot, or it is a scientific notation, or it is a date, it is a dollar sign, a custom currency, or it is a string. The two basic type of variable that you will see are numeric or string. We will usually work with that the data is numeric or string. Some special data are there that are there with deal with the currency level. Number three is the width. Width allows you to determine the number of characters and spaces to enter for the variable. How many? Number three, four is the decimal point. It should be less than or equal to 16. You can get like this. 3.1415, that is the value of pi. 3.1415, 9265 and so on. But it will be restricted to 16 decimal points. Label. This is a very important variable you will do. What does it do? You can specify the detail of the variable, but not much more than 256 characters. And label, when you perform the analysis, the variable name, if you have written something in the label, variable name will not be displayed, but the description you have entered in the label will be displayed as an output. For example, if you have written over here the age, and on the label you have written this age of the respondent, then age will not be displayed, but it will be displayed like age of the respondent. Number three is the value. Value is used to suggest usually if you have the some sort of nominal data or ordinal data, you have to define some values, and we will see what the value column does perform in our analysis. Defining the variables. Okay. Okay, hold on. We are continuing with the values. This is the use to suggest which number represent which categories and when the variable represents a category. Number next is values. We will discuss it in detail when we will come to our data, that what is the value, what the value is. Level of measurement. Everybody, I think many of you understand the level of measurement. That is, there are four different: nominal, ordinal, interval, and the ratio one. The basic analysis of SPSS, because 60 minutes, the first one will be the frequencies I will use. The next is the descriptive measures, graphical representation, and in the last we will use the linear regression analysis. Right? Now I'm starting from the uh, where I had the data. Let me show you the basic files. Let me share my entire screen with you. Okay, this was the questionnaire shared with you. Thank you. I'm very grateful for to the Mr. Gohar for sharing this environmental awareness and practice questionnaire. And thank you, participant. Thanks a lot. You have submitted. I received the 3,200 responses from all over the world. I'm very grateful for this. Let me open this file and download in the sheet. I'm doing it from the scratch. How to download data? You have the file, and first, suppose you have online responses. How to do that? There are so many variables written in the purple. I just want to load it. Let's just wait a minute. Okay. Still being loaded. The first principle of data analysis is the patience. You have to be very patient. If you do not, if you are in the rush, you cannot perform analysis. You have to be very patient about the data, what the data is telling you, and what are you doing. You have to be very calm and cool while performing the data. If you are not, I'm sorry, you will perform that analysis, but you may lead some error. Okay, file, download, and Microsoft Excel. It will download the file. This is the questionnaire. I'm going to open it. You can see the windows of the SPSS when SPSS is open. Data editor. Okay, the Microsoft Excel file has been opened. If you look at this, there is column A, that is a timestamp I do not need. Definitely, for the purpose, most of the researcher do not need that. Also, I'm going to delete it. So this is the file that is has been saved. I'm going to save this. Okay, you have seen that there are about 3,201 rows. Why there, as I have mentioned in the questionnaire, when I got the responses, there were 3200, but it is the last row number is 3207. Why that is happening? Because the very first row has been taken by the Microsoft Excel as the name of the variable. This thing doesn't happen in the IBM SPSS, right? How this happens? Okay, let me show this, that we are going to open the importing the file from the via SPSS of the Excel. Look at this. This is the file, import data. I'm I will take time, I will work slowly so that you can, if you are writing, if you are taking the notes, you can do it. By clicking file, the very first third option is the import data, and the database type are very, so many lines are options are available, like CSV, text data, SAS, data, DBase, Lotus, SYLK, Cognos, business intelligence, like and this. But my file is the Excel one, so I'm going to start with the Excel. This is the file, response files, and now I'm going to open it. It will take some time because the file is okay. The very first is the worksheet. The my data in the form response is one. If you have multiple worksheets, you can select from here. Okay. If there are only one worksheet available in the SPS or Excel, then it will display the basic, the very first worksheet of the Excel. But if you have multiple, then you can select from this one, this point. Nothing to do. If you are observing the data is there, the SPSS is telling you that there are the total, I think, 19 of the variable under study, including the demographics. So I will just click OK. This is, if you observe that, whatever you do, whatever step you take, it is recorded in this output window. If you observe it, that this is another window open automatically when SPSS perform any step. Any step when you ever do on the SPSS data, this window automatically opens and it records everything, right? So if you observe that data view, the data is here. And going to the last column, that is the 3200 value. Whereas in the Microsoft Excel, it was 3201. What happens? Microsoft Excel, IBM Express took the very first line as the variable's name. And the very first is the male who entered the data, and all the responses are there. Okay. Now look at this. What I was telling. If you look at this variable group, do you see any space between this? It is written as what is your gender. But if I introduce a space to differentiate, to understand what is written, what is your gender, and press enter.
What happens? Variable name contains an illegal character. For the SPSS, space is an illegal character. You cannot introduce space like the Microsoft Excel, where it is the space is there. You look at that. What is your gender, and the space is there. If you are observing this, right? This is the what should I say, that this is the beauty of the IPM SPSS, that you have to be very careful about naming the variables. Now next is string type. First of all, I will discuss all about the variable view. Then I will move to the data view. The next is string. Why it is taken as string? In the Microsoft Excel, everything we do not have any numeric variable introduced in this questionnaire. All the three responses were in the some sort of categories like gender. There are what were the responses for the gender? Let me open the question here along with. Oh, there were only two categories, male and female. And but in the what is your age, 1, 2, 3, 4, 5, and 6 categories were there. Okay, no problem. Look at this. What is your age? It is also string. And strangely, we have introduced this as the number 18 to 20, but this has been categorized, not in the number. You have the the classes are there from 18 to 24, non-overlapping 25 to 34, 35 to 44, 45 to 54, and 55 to 64 and 65 and above. These are non-overlapping classes. These are so there is nothing to do with the numerics. And similarly, all the variables are taken as string. But the problem is that if you want to perform any sort of operation, mathematical operation on these strings, it is not possible. The very basic is that in the version 24 and 27 and above, you can perform the basic operations, but not the pure mathematical operations on the string. What sort of operation you can perform? Just at the moment, you can discuss how many males and females are there, what are the different number of occupations, and what is the different education level of the respondents, what are the residential areas of the respondents, and what are the marital status of the respondent. Although you can perform the same operations over these, but these are not good to perform. You have to perform so you have to convert these strings into numerics. For example, let me introduce. If I want to convert this in the numeric, let me show first, please. Data view. What is your gender? Look at this variable. Male, female, male, female, male, female. In the variable view, that is a string. But if I click on the, this is called the radio button. This point is called the radio button. If you click and you convert it to numeric, just hold it on. That what will happen. I click OK, and now I go back to the data view. What happens? Everything is gone because at the back side it is taken as the string, not as the numeric, right? Look, okay, I perform this on this variable, which has more than two categories, as in comma, any other than string. What happens? Look at the data view. Zero. Nothing. Everything is gone. Zero is nothing. Look at this. Every value is zero. You cannot get anything from that. Pressing Control Z, I came back to the original data. So look at this A. At the if you are observing this A denotes that this is a string variable. If you just hold it on this, you can have a very small window that describes that what is the variable. Name what is your age, label what is your age, type string, and then measure as nominal. Nominal. We will discuss it later. One by two. And the same are treated as okay. This is the new variable generated. Nothing in there because I have performed an operation of converting them into the numerics, so it is not possible. So in the variable view, this is not my of a concern, so I'm getting clearing it so that you people not should be confused over here. How to convert these data into the numerics? There are two different methods. One is automatic recoding and one is manual recoding. Why I'm discussing about these two type of coding? Because there are some sort of you can say some has advantage and some has disadvantage. Not the disadvantage, but the limitation that automatic recoding. If you are confirm about that your coding is an alphabetic order, then you can go for the automatic recording. If your programming or the variable are not in the alphabetical order, the SPSS will convert it into the alphabetical order, and it may lead to some sort of confusion for you and for the audience. How to do that? Look at this. The first one thing is, okay, click on the data and transform. The first is transform. You are going to transform the new variable. There are something in the second group of the commands record in the same variable means you are losing the values which is already available there. Record into different variables. It means that you are doing some sort of manual recording. Hold on. Okay, I'm back. Thank you. Uh, Transform. And then is the automatic record. Look at this automatic record. What is this? Automatic recording is that you just enter the value and nothing else. Rename the variable and just press it. Well, how do we do it? I click the automatic record. The very first is look at this. That is a string. I convert into this. And now just enter the variable name. I just read the gender. Okay. Add new name. These question marks will be converted into the gender. Record starting from lowest value. Lowest value means the very first thing which appears in the data, or according to the which is alphabetically, which comes first. For example, female comes first alphabetically as compared to male. So the female will be awarded 1 and the male will be awarded 2. If you select the highest value, then it means that the male will be awarded 1 and female will be awarded 2. But I'm preferring the lowest value first. So I just click OK. Okay, look at this. Old value, new value. Female is 1. That up. Look at this. Another variable has been generated. Right? And then look at this variable label. This is the same what is taken from, but this look at this value. There is nothing in the alphabetic string values variable, but in the numeric, it is automatically converted. This string is automatically converted into the numeric form, and it has the values. If I click, 1 is the female, 0 is the 2 is the male. Usually, we go with the 0 as a female and 1 is the male. If at this point, if you change, SPSS allows you, if you change it as 0, change male as 1, change, and I prefer, oh, I click OK. What happens? Look at this at the very last word. What happens? 1 is taken as male and 0 is gone. So don't change the automatic recoding. Transformation of the variables, please do not change automatically. If you want to change it, you have to do it manually. Manual, I will perform later on. So I will convert it back. One female as the first of I change it to, and then female as 1. Okay, data view, look at this. 2 has been categorized as male and 1 has been categorized as a female. Okay, variable view. I'm coming back to the variable view. That is the measure. Measure is the nominal. There are two types of measure available. Sorry, over here. Scale, ordinal or nominal. Gender is usually taken as the nominal measurement level. So it is nominal by default. The next is what is your age? How to do that? That is also in the, you can say in alphabetical order or the numerics order. So this is very easy. This is this button is called recall recently used dialogues. But you have used recently, you can go for that. Automatic, I reset it. What is your age? I have to define the variable as age. Make sure the variable name, previous old variable name and the new name should not be identical. Okay, add new name, age, okay. Look at this. That is in the chronological order. Ascending order 18 to 25, 35, 45, 55, 65 according to the what happens to the data. Look at this. 45 is taken as 4. So 4, 1, 1, 2, and so on. Number 3. What was the number 3 variable? Education, occupation. There were, let me show you what were the occupation level. These are, do you think these are in the alphabetical order? Definitely not. If it should be in the alphabetical order, it should start from the E, then S, then R, then S, and then U. What will happen with the automatic coding? Let's see. Occupation. Automatically code, reset. What is your occupation? If I write the same variable name, what happens? Occupation and occupation. What happens? This variable name duplicates an existing variable name. It means the variable name should be different from the existing variable name. So what will we do? We will change it. Occupation underscore, that is okay. I'll write it occupation of respondent. Okay, that is okay. I click OK. Look at this. What happens? ERSSU that has been converted according to the alphabetic orders. Sometimes it creates for the analysis, it's good for the automatic recoding, but sometimes you have to be very crucial, like if you are using the Likert scale, strongly disagree, agree, neutral, agree, and strongly disagree. So it will shuffle according to the alphabetic order. You may get surprised what happened. So automatic recoding of okay, let's do it again. Highest to lowest on the same variable. Okay, look at this. Already existing variable was used on the into command error because I have already introduced the command. Okay, I changed the variable name, occupation of respondent. Remove. I remove this. Not allow me to do that until unless I delete the variable. Okay, let's see. Let's see. How do I delete the variables from the data, clear the data, and now I do it for the this one occupation. Occupation underscore. Add new variable. Okay. Let's see. Look at this. Oh, sorry. I have done the same lowest to highest. Automatic recoding, highest to lowest. Reset. That is gone. Highest to lowest value. And then okay. Look at this. This is when you go with the lowest to highest. But this is what you go with the highest to lowest. Means reverse order. You taken one, student two, self-employed three, retired four, and employed in the last as five. But if you go with the lowest to highest, employed is one, retired is two, self is three, student is four, and unemployed as a five. Okay, let's move on to the next variables. Before moving, the same things happens with all the variable. Okay, let me do one for the variable under study. These are the demographics. So the very first, how do you that? Okay, how often do you seek information about environmental issue? This is the variable I am taking. If you click, oh, okay. This is the about the bag usage. Bag usage. Right. Okay. Look at that. There were 5 different categories. Look at this bag usage. Okay, reusable bags. It's if you see that the options were starting from the never, rarely, sometimes, often, and always. After automatic recoding, it is one as always, two is never, Hold on, I show it. Look at this now. If you're observing this, at the right side window, never is the top, two is the rarely, second, third is the sometimes, often is four, always is five. But on the left side window, you are observing always is one, never is the two, often is the three, rarely is the four, and sometimes are the number five. Why I am doing that and how you will suffer from that, you can observe it after this. Now I'm going to do some basic frequencies of the data. How many, what are the gender? One, and we have generated another variable. What is your gender? Okay. These will be similar. Right? Same thing. If I reset it and occupation is this one and occupation of this one and gets a chart how it looks like. Look at this. The very first one, that is you are observing the table, that is occupation, that is taken by default without any coding. But the next one is from the highest to lowest. The numbers are on the same point. Numbers are not different, and the category is taking the same observation. But what happens with the graphs? Look at this. This is the employed, retired, starting from the without coding, and then this is your after coding. This graph is without any coding, basic data, but this is after the coding. Right? This is the difference between automatic recoding and the basic data. Now you can perform the basic operations of the data. Which may include, if I go with another graph side, graph is later on I will do it. But the next is let me go with the manual recording. I think that you have understand the transformation, automatic recoding transformation of that data. Okay, let me start how to do the manual coding or recoding in the different variables. I'm going to do this for you. Okay, the very first is uh, education level or the occupation. Starting with the occupation. Let me show what I did. Click on the transform, recode in the different variables, and then occupation. There you will see, then when I click input variable, then output variable. What is input variable? This is the occupation. SPSS understand the basic property of the occupation variable, that is string variable. Now what is the output variable? You have to mention what is the output variable. In the output variable window, on the very right side, you have to write the name of the output variable. I write it a occupation, keeping the things in mind that I'm not allowed to use the space respondent, and then label. Labels mean the basic description of the variable. Occupation of the respondents. Look at this. In the label, I have introduced the space, but in the name, I am not allowed to use the space. I get it changed. Okay, look at this. Occupation of respondent. Now I have to mention the values, old and new one. The very first one is, which I mentioned in that, is if I tell you that student is the very first value. I write it over. I write it. Keep one thing in mind. Whatever you have described over here, the same spell capitals and case sensitive scenario is over here. Student, write just you cannot write the S over here because in the data it is not there. Value 1 and then add. Now it is student is 1. Number 2 is, what is number 2? Employed. I write it employed and press tab and then OK. The what is number 3? Self-employed. Self dash. Make sure that E is smaller. Employed. Three. Number 4 is unemployed. No spaces there. Employed. 4. And number 5 is, sorry, first retired. Be very careful about writing it. Values and number 5. Add. Continue. Okay. Previously, what we have done, look at this. This is the merit. Occupation of respondent. Over this is also the occupation, but the difference I will show you. Right, the very over here I have to introduce again the same thing which I have done in labeling. The first value was for the student, second was the employed, third one was the self-employed, fourth one was the unemployed, and 5 is the retired. I have done something wrong because in the very data view, this is 5, but over here it is 2. Why this happened? Okay, let me check it out. What is this? Occupation. Employed. Automatic coding says that it is 5. No, this is 2. This is the correct coding. Occupation of the respondent, because look at this. 2 is the employed. So the variable is, this may happen in the automatic recoding. Oh, sorry, we have, why this is, look, I just answered this. That in this point, the 5 is the, because we have done with the highest to lower, so implied is the last category, number 5. But when we have done it converting in the manual coding, then it is 2, because in the our question here, implied was appearing at 2, which is the very correct answer. So I prefer with the manual recording, taking that every step, every variable into under consideration by recording into different variable. In this way, you are able sorry, you are able to understand the complete file, how many variables are there, what are their different levels, what are their different categories, right? So variable view. Now look at this. Nominal. This is not the nominal. This is in fact the ordinal variable. Right? Now you can perform any sort of mathematical operation if you want to require on the occupation of the respondent, because it has been converted from the string to numeric. This is the thing. You can observe that by default, SPSS has taken it as a string, but now you have converted this variable into the numeric form. This is how we perform the analysis, how we convert the data, which is string data, into the numeric form. Due to shortage of the time, I have completed my file. So I'm opening that. This is the final file. If you all can observe that these are the variables: gender, age, occupation, education level, residential area. If you see that the complete name, marital status, and that is the question 2.1 means we have uh, 3 sections. Look at this, section 2. Section 2, the very first question, and there were 8 questions in section 2, and there are section 3, and there were 5 questions in section 3. So I have converted these as taking this type of transformation, recode into different variables. So what data shows? Look at this. This is the key. If you are observing, this is the button which shows the value labels. When you have converted the data, if you press it, it will be shown like that, which was the original file. But there is a coding behind it. So it is, if you, this is the very good key to see if there is something missing in the data or not. Let me go just last 3200. Every observation is there. And the very first step, if you want to see how many values, if there are any missing observation, now I'm moving to the analysis part. I have done with the coding and importing. So the first step is analyze, descriptive, and frequencies. Before going to that, I go with the analyze. Code book is very good thing. So let's start with the code book. Take all the variables and put in the code book and press OK. What happens? Count, you get this. Every variable with its complete detail is there. What is your age? Numeric, format F1, this is ordinal measure, role input, and the very valid values are there. There is nothing like missing observation. Right? If there is any missing observation, then it appears in the very valid values 1, 2, 3, 4, 5, and the 6 will be missing. Okay, since the data has been clearly, carefully observed, so you can see that the last variable, question number 3.5, strongly disagree, disagree, neutral, agree, and strongly disagree. If we do with the, if we go with the automatic decoding for this last variable, what happens that it will be automatically starting from the agree, then disagree, then neutral, then strongly disagree, strongly agree, then strongly disagree, right? So it will create a little bit confusion for the reader and for the researcher also. So used to be this type of data appearance, so we are doing this. Now what we have to do, the next step is the descriptive and frequencies. I take how climate change charts, bar chart. There are three different charts available. Pie chart, histogram. I just prefer with go with the bar chart right now. Continue, format, ascending values. Okay. The very first thing, that is gender. Oh, I have clicked something else. Look at this. There are 31%, 31 persons respondents who are not aware of current environmental issues. Strongly, slightly aware, 353 people are there. Moderately aware, there are 1006 responses. Respondents who are moderately aware about the current environmental issues like climate change, pollution, and etc. It's a good number that 1313 people are aware about the current environmental issues like and extremely aware. A little, uh, not so good number, 497, that are extremely aware about what is going in the climate, why the pollution is creating. Now the thing is, I have generated a pie chart. You can perform many operations, not like what can I say? I haven't performed any operation in the Microsoft Excel, but I can go with this. If you double click it, what happens? A new window appears that is called as chart editor, right? If you want to get the number, how values are there? 353, which are not aware at all. Sorry. And then extremely aware, different, very aware. This is the variable who are extremely aware. This one. Okay. If you want to slice it, just click on this point, slice it. You get the sliced pie chart. And when you close it, the chart editor, it looks like this. If you do not want to get the pie chart, okay, no issue. Click on this. You on the clicking the variable pie can be converted bar. Apply. Okay. You see that on the same data, you just in the back end, it is a pie chart, but now you have converted into the bar diagram and just close it. And look at this, what happens. Just look at it. It has been converted into the bar chart, and vice versa you can perform. Right? The next is how to get the, you have done a score. This is a very good command. On the wrong side. This is, I'm going to close this file, which we were doing for the time. I'm saving it. No. Analyze. Crosstabs. What is crosstabs? Crosstab is basically used for the two attributes, qualitative variable, not the quantitative variable. Well, you have the data like in the nominal scale or ordinal scale or in the nominal scale. So you go with the crosstabs. Basically, it is the basic, the very famous is the chi-square, right? So if you want to see what is the impact of residential area and how important they observe, or do they seek information? As per the residential area, I select chi-square. Look at this. The residential area versus how often do you seek information about environmental issue? And there you observe that Pearson chi-square 0.005, that yes, there is a strong relationship between the urban, suburban, rural area and the seeking the information about the environmental issue. People living in the urban are most concerned with the change in the for the seeking the information, what is going on globally, what is going in the climate, what how the pollution are impacting our lives. In suburban and the other rural areas, you can see uh, residential area versus the how often they seek information. This table is there. You can interpret it. In the very last, if you are observing 2266, these are the people totally living in the residential area, urban area, 287 living in the suburban area, and 647 are living in the rural area. And comparing these results with the seeking informations, living. So I just explained this one, this value, that is 699, or okay, 1007, the highest value available in the data. What does it shows? It shows about 1392 who are seeking option. There are 1007 people who are from the urban area. Among the 1392 total respondents who often seek information, there are 1007 people who are living in the urban area. And the lowest one is 1. It means the people who never seek information, there are 29, and only one person who is never seeking information about the environmental issue is living in the suburban area. Right? It is the description of this table, and now this is the second table. The chi-square Pearson chi-square value is 22.154 with 8 degree of freedom. Degree of freedom, how degree of freedom is calculated? Look at this. 1, 2, 3, 4, 5. 5 minus 1. How many categories? 5. 1, 2, 3, 4, 5. 5 minus 1, 4. And how many categories on this row side? 1, 2, 3. 2 minus 3 minus 1, 2. 4 into 2 are the 8 degree of freedom. And if we see that 0.005, it means it's less than our critical value, which is usually 5% means 0.05, but it is value is 0.05. It is highly significant observation that yes, there is a strong relationship, strong evidence of that the residential area and the information regarding the environmental issue are highly significant. Means if you are living in the urban area, you do seek information about the environmental issue and vice versa. Okay, the next is I perform another test, cross tab, or this can be as perform non-parametric test. This one. If you see that, the same thing we perform like this. But if it is given already over there, we do not go with that. We just use the cross tabs and perform our required results. Now, I move on another type part of this file, that is, if you want to compare, the next thing is, look at this variable view, section 2 and section 3. If you want to get the total of the section 1 and section 2 and section 3, what are the sum of the answers, or you can want to perform any type of advanced level of means what are the average, what are the standard deviation, how they are corrected, what are their variance. So you just add them. How this was calculated? Just click on the transform compute variable. In the compute variable, there are, I have told you, there are 8 questions in the section 2 and 5 questions in section 3. The very first, if you looking at this, question 2.21, I click this. I named it sum of section 2. Right? I click it sum of, and then type of the label do not, that is put by default it is numeric. If I sum of 2, no, I don't want to write it. Then click plus. Look at this, plus 4, 5, 6, 7, plus 8, and then okay. Oh, look at this. I have introduced the spaces sum of section 2. So it has informed me variable name contains an illegal character. Okay. I understood. Then I click OK. What happens? Look at the data, sum of section 2, and similarly, I had completed the section 3. If you want to take the average, okay, I go with this one, last variable, analyze descriptive of last variable, sum of section 2, options. I need the mean, I need the standard deviation, I need the variance, I need the range, how many and sum is there. If there is a skewness is there, okay, continue. Okay, I want to check the skewness. Okay, look at this descriptives. There are 3200 observation, range statistics 31, minimum value is 9 and the maximum value is 40. Some statistics, mean of statistics is 29.9406, standard deviation is 4.36, approximately 4.5, and skewness is negative, minus 0.338, slight negative skewed variable. If I go with the graph, histogram, look at this. This shows a moderate, approximately normal distribution, very approximately, but slightly modifying to the negatively skewed data, but it can be transformed easily, but it can be taken as the normal distribution to perform additional type of uh, analysis. This was the section 1 of my presentation. Now I'm moving to the a file which contains the qualitative data, mostly qualitative data. Before moving to that, you are observing that the next file contains this type of information. A data frame with 200 rows and 10 variables including ID. ID is student ID, gender, male is 1, female is 0, race, student race with the level. Levels are Hispanic, Asian, African, American, and white. SES, socioeconomic status of the student with levels low, middle, high. SCHTYP means type of school, means are the school public or private. PROG, program in which the students enrolled, that is general, academic, or vocational. Read, it is the standardized reading score. Write, standardized writing score. Math score, science score, social studies score. Now I open the file for you. Look at this. This contains two different types of data. One is for the 1, 2, 3, 4, 5 are the ordinals, and 1, 2, 3, 4, 5 are the scale variable, which we are going to discuss about it, how to perform the different quantitative aspects, type of test on this. First of all, I go with the, I'm not going with these 5 variables that you can perform any sort of information like I have discussed in earlier, which is chi-square or something else or whatever you want. But now my major goal of interest is dealing with the scale variable, how to perform the different types of statistical analysis for the scale variable. Okay, the first thing I'm going to descriptive and getting the averages, standard deviations, minimum, maximum, range, and see if there is a skewness or not, the data. Okay, look at this. Reading score, there are 200 observations. Oh, one thing I forgot. Thank you. I got it. If you click on the this table, I just click again. Look at this. I just click on the table, double click to activate. And you are not able to understand, look, just pivot it, transpose. Now it's like this. If you do not want to transpose it, transpose rows and column. Previous one. If you want to insert caption, you can. If you want to break, the points you can. If you want to rotate inner column labels, you can also do that like this. But okay, my concern is about the skewness. That is, writing score is highly skewed, and social science score is skewed. I want to see that if this is correct or not. I go with the graph, legacy graph, histogram. I have observed that which one? Writing score. Okay. I observed that yes, there is not the normal distribution shape like this one. This is some sort of approximately normal distribution, but the writing score is not the normalized type of data. The next one was the social studies score histogram. I remove this and check it whether it is true or not. I observed that is highly skewed distribution. So you can observe that yes, these are you can take the advantage of this descriptive statistics. Now, the very first test I'm going to apply is the t-test, one sample t-test. I have a limited time, approximately 7 to 8 minutes to complete this. I go with the analyze, compare means, one sample t-test. For example, if we go with the writing score, and we observe that the average value should be 50. However, is that okay or not? Test value that average mean score of the writing score is 50 of the 200 students. We test it at the 50 and see that if you want to increase the confidence interval percentage, you can get it 90%. 95% is by default. Even you can more precise as a 99%, but 95 is okay. I go with this and look at this. Yes, t-test is significant. Writing score is a very significant. Less than 0.001, highly significant. The mean is highly different from the our estimate observed value 50, because the mean is 52.7750. Which shows that yes, the mean is different from our observed value that 50 is not. Now I go with another compare means. For example, there look at the file frequencies. I need frequencies, gender, how many male and females are there. So you can, if you want to take data for differently for male and female, you can perform this. SPSS will do it for you. You have to do the data, split file. I repeat, click on the data, split file, and give them compare groups with on the basis of what? On the basis of gender. Okay, click OK. Now look at that. Sort cases by gender. Now what you do, if you take the frequencies, descriptives of one variable only. Look at this. Earlier, it was the reading score was for the combined values. Reading score 248. The mean was 52.23. But over here, you can observe that the file has been bifurcated, distributed into two categories on the basis of gender. That is a male and female. There are 91 males and 109 females, and the average mean score of the male are 52.84824 and the average score of the female is 51.7339. What does it show? It shows that the average score of the males are higher than the average score of the female. Standard deviation is approximately same 10.50 as compared 10.05. To perform the, you can say the two sample t-test, first of all, I have to remove the split. Okay. Analyze, compare means independent sample t-test. That is rating score. Grouping variable is gender. Again, analyze, compare mean, t-test, rating score. Gender is a grouping variable, define group, 0 for female and 1 for male. We have to be very careful about grouping variable, that what are the basic of the values behind it. Okay, you can see that there are two rating scores. Equal variance is assumed, unequal variances are not assumed. If we see in the above table that the variances are approximately same, we are taking it as a same observation. Approximately equalize the variances or the standard deviation. So what we will take, the equal variances assumed. I just take this and pivot transpose. This is much better for me to explain. Okay, Levine's test for equality of variance, that is highly significant. Yes, there is the difference. Our hypothesis was that is there any difference between the reading score, uh, writing score of the male and female? So we observed that yes, there is a difference between the writing score of male and female. Look at the above table. This one, if you see that the male writing score is 50, whereas the female writing score is 54. So this confirms in the following table. My question at that point is, last thing is that, is there any relationship or we apply the linear regression? So it is very always commonly said that the your writing score depends on your reading. Your writings depends on your reading. How powerful your reading habit is, it means you are more powerful in the writing. So I'm going to analyze this thing, regression. Okay, analyze, regression, linear. Dependent is what? Writing. Writing is depending on what? Reading. I get the plots. Histogram. Statistics, if I need moral confidence intervals, no required. Descriptive, we have seen that. And just, okay, look at the method. There are 5 different methods. Enter is the basic method. Stepwise means taking one for the more than one independent variables, remove backward and forward. These are basically used for the multiple linear regression. That stepwise remove means take one and remove the next, first remove it and then take the next one, then and so on. Backward means starting from the last variable to the forward means first 1 2 3 4 5 variable of explanatory variables. Okay, I take, since there are only one dependent and one independent, so this is called a simple method, that is called enter, or we check it out. Okay, regression variable under dependent variable is writing score, variable entered is the reading score, Model summary, R is a relationship. R means the correlation coefficient between them is a 0.597. It is moderately good, not so good. ANOVA, yes, there is strong relationship. 0. If we take the less than p value that is less than 0.001, predictors constant reading score, that is very strong relationship between the regression model explains coefficients. If we write it model as constant is the 23.959 with the reading score coefficient alpha, and alpha is the value of alpha value is 23.959 and beta value is taken as b is 0.552. This 0.552 means that if I take this in the Microsoft Word, how to explain this? So we are going to switch dark mode, to switch off the dark mode.
Amisa, we can move towards the question answer session by 12:45. Is it okay?
Okay, taking this, what does it mean? It means our writing score is equal to 23.959 plus 0.552 reading score. This is the model generated by this data. If 0.0052 units per increase in 1 unit increase in the unit score in the reading score, then it will be increased 23.959 plus 552 score in the writing. So this is the basic model generated by the IBM SPSS. Okay, coming back to this, look at this. This is some sort of standardized regression residual that is approximately equal to normal distribution. You can perform other analysis, but for today's I have been for the fitting linear regression models was the last topic for me, and I'm sure I have completed one sample, two sample, histogram, descriptive. So this is all from my side. I think what I have written. Now I think the questions are there. So I am open to them. These were the types of
Hmm. All right, Shamisa, thank you so much for such an insightful session. Now we have opened the chat for receiving questions, and we are going to start posting these questions to you. The first category of questions that I would want you to, reflect on and to respond to are about different operations. So we have a question where different participants have asked about the operations of SPSS. If you have frequency less than 5 cells count, more than 20%, does it violate the chi-square? And second, if you have big tables, not 2 by 2, so what exact criteria should we meet, because SPSS can't compute it? So basically, if you have lesser data and if you want to run some operations, what should researchers be mindful about?
if you have a 2x2 table,
So
it's
we can't
good.
hear you.
If you have a 2x2
I mean, you
table,
have to unmute
then
yourself.
it's
Mute it.
okay. But if you have more than 2x2 table, as I have showed you, that
No, we still can't hear you. Please unmute yourself.
am I audible?
Yes, sir, you are.
Am I audible to you? Okay. Okay. Thank you. Let me show you the output window that in this table where it is price here. Look at this. Look at this. These are not the 2x2 table. These are in fact the 5x3 table. Yeah, 3x5 tables. In fact, the 3x5 tables. So you can perform the, if you have the higher number of tables, higher number of rows and column, SPSS can easily deal with it. No issue.
All right, thank you so much. Our next question is, how can I organize over 90 Likert scale items across 6 objectives into a single SPSS data set efficiently without creating multiple tables?
19 Likert scale, it's okay, no problem. You can do that. First I'm hearing the 19 Likert scale. Otherwise, I have worked with the 11 one. You can introduce as many values over here. If you want to introduce 6, 7, 8, 9, 10, 11, up to 19, it depends all in the value levels. You can introduce as much as it can. But make sure they should be not the replication one. If I do introduce a 1 as something SD, and I go for the SD, there is a label already defined. So you have to replace the existing variable first, then it will be uh, available. Otherwise, it is not possible.
All right. The next question is, what are the alternatives to cross-tabulation when analyzing multiple control variables simultaneously in SPSS?
Okay, analyzing these are the tests available for the non-parametric. If they, first of all, you have to check if it is with the not violating the chi-square values, chi-square assumption, then you can go with these different non-parametric tests available. If you are doing with the multiple response sets, then you have to define you can go with the multiple response data set. First define the variable set, then go with the parameter or available test. So definitely those will be non-parametric.
Is it possible to use control variables in regression or ANOVA?
Yes, it is quite possible if you have to two different type of variables like the control and the experimental. You can perform all type of information. You can get all type of information through the SPSS. It's not a big deal.
This is a very interesting question. The question is, age is marked as nominal in measurement, but in recent PPSC question, it was marked as ordinal. What should age actually be, nominal or ordinal?
In the recent studies, yes, I understand that. I've come across that in the discussion group that age is not taken as a nominal as so long in the next, but you can say that we are not much aware of the advancement in the science and technology, so we still take it as the nominal, but it should not be taken as a nominal. It should be taken as the ordinal variable. Nominal as those which do not create so much impact on the data, like male and female, that are the already we defined it, like the marital status that is already predefined. Age is a category which you can change. I have from 18 to 24, 25 to 34. You can change it 20 to 24, 25 to 30, and so on. So it should be taken as the ordinal variable, not as the nominal. But gender, there
Yeah.
are only 2 or 3 types.
Yeah.
I have not discussed over here that prefer not to say there is another option.
Thank you so much. This explains it. There are many questions related to chi-square tests and Fisher exact tests. Can you explain that when should researchers use either of these?
Chi-square test is the, you can say that is a parametric test. Fisher exact test basically deals with the nominal attributable data, but when it is not possible or some sort of confusion about the parametric assumptions of the data, then we validate it with the Fisher exact test.
We have questions about indexation in SPSS. I'm sorry, I'm not a quantitative analysis person. Quantitative research is not my forte. So I may sound a little bit alien to these terminologies myself. But we have a question about indexation and when should we do it and what are the reasons behind it?
I'm just hearing the very first time of this, so I can't comment on this question. Sorry.
Oh, all right.
Simple.
Also, when should researchers apply Monte Carlo test?
Monte Carlo test. If you follow the assumptions or the data is not Monte Carlo.
We can't see your screen anymore.
Gee, I have done.
Is this a technical glitch or are you
Yes, that is
shutting files?
it is used for the computer simulation for the significance of the statistical test, particularly when the distribution or status is unknown. And it is difficult to determine analytically, then we go for the Monte Carlo test. Basically, this test is being applied when someone is not sure what distribution the data is following. Basically,
Okay.
and it largely depend on the large data set, not the small one.
All right. So basically, Monte Carlo test is meant to be for large data sets.
Yes, it is. It is.
How large should be the data set?
It depends upon the number of observations you have collected. More than
Okay.
10,000, 20,000. 20, 30,000 is not a big deal nowadays because of this AI and the supercomputers. It is very quite possible to deal with this small amount of data of 23, 30,000 rows, 40,000 rows. Not the big
Hmm.
data is being in million rows of the
Hmm.
same topic.
Hmm. So while we are talking about rows and data, usually researchers, the base file is made using MS Excel. So we have a question, does SPSS handle CSV files the same way it handles Excel files?
Yes, let me share it
Okay.
that I have shown.
The tests, is it possible to run the quad test on SPSS?
Just I answered the very first question, importing the data. If you look that data,
Are we,
Yes.
which question are you answering?
the SPSS or Excel or CSV data file.
Okay, all right.
So Excel dataset, CSV dataset, text dataset can also be handled with the SPSS. Even the SAS file, stata file can be opened in the IBM SPSS. You can import data and do your manipulations, whatever you want.
Hmm. All right. And now talking about this very question that can we run quad test on SPSS?
Quad test.
Hmm. And what is it for? If you could briefly explain that also.
No. Quad test is new for me. Sorry.
So can we run that test in SPSS?
We can run it. But I've never done it on the SPSS quad test on SPSS. But
Which
for the
software
quad
do
test,
you use?
let me tell you, for the quad test, R is the very good.
Okay.
R is very good for running the quad test. Or
All
you
right.
can, or you can import the files of the Python, like so many libraries are over there, NumPy and like these.
Hmm. So we have another question that most journals prefer smart PLS when the data is not normal. What do you say about it?
No doubt, SmartPL is a very good software tool, but SPSS can be used as compared to the smart PLS. It depends on the requirement of the journal. Many journals require SPSS. Maybe some journals may require the smart PLS. It depends.
Depends on what?
Depends on the requirement of the journal. Most of the operations which are similar in the smart PLS and those are also available in the SPSS and even in the Stata.
So we have another question related to data assumptions that if the data is not normally distributed, will SPSS still allow us to run parametric tests like t-tests or ANOVA? And if it does it send a warning to the user about the abnormal distribution of data?
Okay, first of all, if first you have to check the normality about the assumption of the normality. If there is non-normality in the data, you can go with a non-parametric test, which can be more elaborative as compared to the normal data. If some that is type of that type of data is available in front of you, I usually prefer you to go with the non-parametric test. And if you want to convert that data, applying the different transformations like taking log or taking square root to making the data normal, then it is possible to make the data normal and apply the other. But after all, you have to inform the people, your audience, that data has been transformed to the normal distribution by making this transformation. Then you can apply. If the question about that, it gives a warning, no, it doesn't give the warning. SPSS doesn't give the warning that the data is non-normal, but it needs that preferred to apply the non-normal, non-parametric thing.
Okay. We have a question about another test, which is Shapiro-Wilk test. I understand that
yes.
it's a test for null hypotheses. Can we run that on SPSS?
Yes, this is non-normal test, non-parametric test that is available in the SPSS.
Mm-hmm.
That is
All
available.
right. And that's all about it. I think we have taken all relevant questions. There are many questions which are, if you do a little bit of research using AI or Google, you'd find the answers. For example, a lot of you are asking, where can we get the SPSS? How can we download it? All of these things can be, you can troubleshoot these issues on your own.
Yes, definitely.
Yeah.
Even I prefer the AI if I get stuck somewhere.
Absolutely. And there are tutorials available
There are so many
to
tutorials.
run different tests as well.
Yes, absolutely, absolutely.
So, Asif Saab, thank you so much. This was a very informative session. We have received high appreciation in the comments.
Thank you.
And just to let you know that in today's session, we had participation from 40 different countries, representing a range of countries from the European region, from Asia, and also Central Asia and the Arab Emirates. So thank you so much for sharing your knowledge with us, your expertise on SPSS. It's a very powerful quantitative analysis tool. And definitely young researchers as well as mid-career researchers are always looking for new tips and new knowledge on, using SPSS. So thanks again. And for the rest of you.
CLT especially for giving me the chance.
Well, it has been 15 years that you're working with us, and definitely, I mean, it's your knowledge and your command over this particular tool that brings you back every year in the research methodology course. For my participants, I have an announcement to make. We have another webinar today, which will start at 2 o'clock, and this will be the 14th webinar. And the theme and the focus of this webinar is conducting and publishing systematic reviews. So now, after we have talked about different tools for data analysis, let's think about different ways of literature review and how technology can help us and how can we enhance the body of literature by following different strategies of literature review. So please join us back at 2 p.m. today. And with this, I would like to close the webinar. Thank you again. Thank you, Asif Saab, and we hope to see you again at 2 o'clock.